Right? Hello, everybody. Welcome to our session, Build GenAI Applications with Google Databases and Cloud Runtimes. I'm Harish Jayakumar. I lead the Global Solutions team here at Google. Today with me, I have Rhee, who's our Senior Product Manager in the Google Cloud Databases team as well. Our agenda is very simple today. We're going to talk about the overview of our GenAI journey. We're going to get into the components of building a GenAI application database. Then we're going to take a demo and show how it all comes together. And finally, we're going to get in the next steps. The first one, let's look at the overview of GenAI journey. Long ago, so long ago, eons ago, we invented fire. We invented the wheel. Then we invented applications and databases. And then this thing called GenAI came 2 years back. It's 2024, and it's almost illegal to do a tech talk without GenAI. So, the technology is awesome, but what I find really interesting is the new experiences that this GenAI is actually starting to create. And when I talk about these experiences, I'm going to cover 3 of them over here. First, is generating creative content. Just by using a little bit of instructions, you can actually create descriptions that you need for a product. Say, suppose you're a retailer, you just have a new product that's come in. Laborious process involved in writing the description and attributes with that product. Where do I take and keep that product in the product catalog? That process would take about weeks. Now with GenAI, you can do this in literally a few hours. The second is being able to retrieve, and when I talk about retrieve, I talk about domain-based conversations. What I mean by that is, how many times have you gotten on a chat interface and be like, if they just knew the history of my case, how can we get that history and get the relevant content for them based on that user's history? And then third is augmenting. Here I talk about semantic search. So semantic search, the key part over here is we take the searcher's intent in mind when we're actually doing the search. Now this is different than keyword search, right? Where you enter a keyword, you look up that keyword on a website, if that's available, that web page is returned. Whereas in semantic search, it's the intent. Example, I ask you, do you like this website? You're like, yes, I like it. What did you like about it? When I say, what did you like about it, that it means that website. That's the semantic piece over there. That's semantic search. If you're using Google Photos today, semantic search is already integrated into that. Now, we all knew that AI adoption in enterprise is going to surge in the coming years. But how much it really is literally staggering. If you look at it, just in 2023, we were about 5% of enterprises were adopting GenAI. And we believe that it's going to go at 80% by 2026. This is by sources Gartner over here. This is the key part over here. That's a 15x in just about 2 years that we're going to get. Now, when we talk about using GenAI in production, I'm talking about these models being used, the model as is, as well as API calls. But how can we achieve this amount of jump scale? You guys, developers. There's about 10x more developers and data scientists, according to the Bureau of Labor Statistics. That's an order of magnitude innovation potential with AI. As a result, we believe application developers are going to drive the bulk of this innovation in applying GenAI business problems. Now, this is not only going to be for building new applications, but also taking GenAI and integrating them with your existing applications as well. But there's a few hurdles. So over the past year and a half at Google, we spent time talking to a bunch of customers, a bunch of executives as well. 3 main barriers were called out. 58% of them reported skills gap as being a major barrier to adoption of AI in the enterprises as well. Now, even if you fix that skills gap, there's still the concerns around data quality and availability. These data silos and having structured and unstructured data issues, do we have enough clean data to go train? Because remember, high quality data is needed for high quality algorithms. Lastly, almost a third of the companies called out cybersecurity and security as a huge barrier for these adoption as well. Now, this is mostly due to lack of understanding of these vulnerabilities. So how do we go about this? So one thing is very clear. Building applications like it was done in the past, where it was built in the past, is not going to work in this AI transformation era. So what's going to work? before we start building the application, I'm going to give you a strategy called the 3 P's strategy: proximity, platform, and productivity. When I talk about proximity, keep your data and your applications closer together, because this is going to help you maximize your performance as well as reduce your latency. Second, platform. Every day, there's a new model that's coming out. LLMs are the new application. So you want to think about it as an end-to-end, not just in terms of these LLMs and models. You really need to think about it from a platform perspective, a fully integrated platform that can take these LLMs, your data, application, APIs, and bring them all together as well. And then finally, productivity. We just talked about 10x of productivity, 10x of developers over here. Bringing AI-assisted productivity tools to this organization, especially on the developer side, is going to help solve all these problems on that. Since I talked about developer productivity, let's jump into a little bit on that. I'm not going to cover this as a topic because there's multiple talks I'm going to reference on this. But today, we talked about Gemini. Gemini is going to completely improve the developer productivity. Now, if you're a developer, you build an application, you ship it, and you run it. So you're familiar with the inner loop and the outer loop. As you're building these applications, there are still these things that we need to do. Generate code, summarize the code, unit test generation. With Gemini, you can actually do a lot of this. There were some of them that were showcased in the keynote today, and tomorrow there's going to be more in the developer keynote as well. But very simply think about this. You're a new developer, you just joined a company. You can literally take the entire source code, shove it into Gemini, and that'll be able to summarize it and explain it for you, and you can get started immediately with that. That's the level of productivities that we're giving. And I don't know about you, but I don't like a lot of writing comments and unit tests. This does that for me. So, a lot of things on the inner loop side, similarly on the outer loop as well. So this is how, with Gemini, we can improve the developer productivity to write these applications both on the inner loop and outer loop. So great, now we're going back to history again. We invented fire, and now we're coming back to applications and databases. Now, how do we take this to the GenAI journey? We start adding an LLM model. LLM, large language models, built with millions and millions of, trained with lots and lots of data points. How do you go get these models? We have 2 options. One, you can build the model, or you can consume the model. So let's talk about each. We talk about building models. This is mostly done by data scientists. They've kept it as like a specific thing. They would train it for their specific use cases as well. But building models is a little bit more, multiple steps involved in it. First, you got to get the data, structured and unstructured. Then you got to cleanse the data engineering, get the analysis, everything associated with it. So there's a multi-step process on this. But with Vertex AI, this entire ML workflow comes and it's built in, and it can be used integrated with Vertex AI as well. So that's the one way to do that. Or if you don't want that, you can go one step lower on this. If you're already there in the Kubernetes ecosystem, you already know about containers, kube, you can still do that with GKE. You can build your model, wrap them up in a container, put it on GKE. GKE takes care of autoscaling, autopod, and you can do it over there. Or you can go one more level down and go straight up to the CPUs, GPUs, and TPUs, and you can actually build your models right over there as well. So depending upon how you want to be able to go use them, you can use it. The key thing over here is you want to accelerate iteration speed between these models without the infrastructure overload. Because as and when you get more data, you want to train the model, and you want to go back quickly, and you want to do that. So that speed is super important when you're actually building these models. Or once these models are built, you can just go consume the model. There's so many models out there. You can literally go to Model Garden, pick up any of the models that you want, depending on the application if you want. You could pick up ImageGen. If you know the use case of your application, what model you want, you can go pick it. Or Vertex AI comes with AutoML. You don't need to think about which model you need to pick. You can just give that your application, and that picks the model for you as well. Again, here, you can still use GKE, and you can still use your models on GKE as well for training itself. Now, I talked about AutoML, so I'm going to show you a really cool thing. If you haven't stopped by the Vertex AI booth, I would highly recommend going there. I was there last evening, and they do the penalty kick shots over there. So you can actually kick, and then the model gets trained, and immediately it gives you feedback. So here, what happened was AutoML was used to find out where the ball was placed, how my feet was, and then that data was then given to Gemini. Gemini became a trainer and gave me feedback on how well I should be improving my kicks. So I'm going to trust this model because it gave me a really good high score. So for this case, we're just going to pick up a model. So we're starting to cook, right? We got everything that we need. We have an application. We have a database. We have an LLM. Is that enough? Not quite yet. Because LLMs are not completely enough for your enterprises. Because what you still need, you need accurate and up-to-date information, which is pertinent to your enterprises. And then you want to be able to give those contextual user experience that I talked about in the first slide. And then finally, for developers, we want it to be easy to build and operate as well. So what do? Business data. So we get your business data now. This business data is going to bridge this gap between your foundation models and enterprise AI applications. For some reason, that curve didn't come through, but it's basically bridging the gap between the applications and your models. Now, how do you bring these models? So to bring your enterprise data, you have 3 ways: prompt engineering, fine-tuning, and RAG. So let's talk about each. So prompt engineering, easiest of them to use, right? Because it's a mechanism to instruct the model on what is needed. The better the prompt, the better your results. So basic commands, very cost efficient, point in time. However, it's a little bit inconsistent. It depends upon how you face the prompt. You also have variations, whether it's few shot, single shot learning, depending upon how much you want to give to the prompt as well. Then there's fine-tuning. Fine-tuning basically takes all the labeled data, and then it retrains it with your enterprise data, your company data, or your industry data as well. So this is almost like going back to school. The way I kind of explain this is like updating an app on your phone. You have to update the entire app for you to see the new results. So of course, it requires a little bit more technical skills, but it's more tailored, more accurate for you. It's point in time, but still has updated results. It is expensive, for sure. Talk about compute resources. And then you have multiple variations with full adapter and prompt. And then could we find a balance between the two? That's RAG, Retrieval Augmented Generation. This gives you more control and also includes an internal knowledge base and gives you real time based on your results. So it basically programmatically looks up your relevant information at that time. That's why it's grounding over here. It more scales with data, cheaper, and no fine-tuning required as this. Now the question that typically comes up over here is, which should I use? With any tech answer that everybody has ever used, the answer is, it depends on your application, on your use case. For example, prompt engineering is a must. You should have good prompts. So it's going to be applicable to almost all your use cases. And you could use a combination of fine-tuning and RAG as well. An example we were discussing was, let's take, for example, you're building your employee data. Fine-tuning, you could build it with your employees' data, completely with it. So you're retraining it based on your employees' data. However, if you have something like salary, social security number, you probably don't want to put it there. You could use it with RAG. So that's where you're using a combination of both these models when you're using it with the employee data. So for this, we're going to go with RAG for building. So really quick, how RAG works. When you simply ask a question, what typically answers is straight away goes to the LLM. LLM synthesizes and generates the answer for you. But what happens over here, once you have a question, it first hits the database. In this case, it's going to be a vector database that's going to be populated with your enterprise data. And that's going to retrieve the top chunks, which is much more relevant to the query that you send. I'm going to talk about how you populate that database in the next step. But before that, what do I mean by top K chunks? So chunk very simply is like as humans, right? We have a limited memory and limited context. It's the same thing with LLMs as well. If it doesn't fit into that limited memory or limited context, you start breaking it down into smaller chunks and store them. That's these chunks that we're talking about. And then it picks the top K chunks, which is the topmost results associated with it. And then that enterprise data is added along with the query you gave. That is then sent to the LLM, and that generates it. So that's why you're retrieving it. And this happens at runtime. You augment it with the prompt, and then you generate the response given back to the answer as well. Now, you saw very quickly I talked about putting that database. So populating the database, how does that happen? The key of that is what is called embedding models. So what does that do? Basically, let's look at your data, whether it's audio, video, text. You feed that data into these embedding models. These embedding models generate vectors. That's what is called as vector embeddings. A vector embedding is a numerical representation of this data. And these vector embeddings are then stored inside a database. So this embedding function basically, embedding model, generates those vectors which are then stored in your vector database. The way it stores it is also super important because like-minded things are kept together. For example, let's take color, blue, green, yellow, those all sit together in the database. Whereas if you take, for example, like, car, bus, ship, all those sit together as well. That's why if you see in the previous step, when I say the top K chunks, it's a chunk of relevance to the data. So how close it matches is how it actually retrieves it over here. So the embedding models generates that, and then it stores it in your operation database. So we took everything into account over here, embedding models, LLMs, application, and database. Let's walk through with an example. So now I have a query that comes in, okay? Before that, we've already prepped it. So my prep step, I already covered it in the last 2 slides. Your internal data is basically embedded in the database as vectors. Now let's assume a query comes in. A user asks a question to the GenAI application. GenAI application, you would typically you could run it on Cloud Run. It comes with, it provides frameworks with things like LangChain. It also has an HTTPS endpoint. And then that question is then entered into the embedding model. The same embedding model that we used before in prepping is what is used here. So this embedding model will now generate a vector, which will then be compared to the database that was pre-populated in the previous steps that we talked about. So a similarity search is then done here. That returns the relevant data. That data is then added to the prompt, which is then sent into the GenAI, into the LLM as well. So in our question over here was, what's your return policy? The query comes back, it calls the model. Because the return policy is specific to your enterprise, then it returns says, our return policy is 60 days. So that is then taken and then added to your query before it sends it to the query. All right, so I've done the really hard work of explaining all of this via slides. So to do the easy work, I'm going to call Sean to show this via a demo.
Oh, there you go. Welcome, everybody. My name is Sean. I'm a product manager on the databases engineering team at Google Cloud. And today I'm going to show you the easy part of how to actually put together a GenAI app with containers, databases, and AI tools. Now, Harish talked as an overview of how the entire process works. I'm going to start mapping products to these processes and start to build the app. For the GenAI app, you can run this anywhere. In our case, we'll run this in Cloud Run because it's an easy to get started serverless compute architecture. For the database, we'll be using AlloyDB, which is a vector-enabled Postgres-compatible database. It's an excellent choice to get started. You could use other databases as well, but in our case, we'll be using AlloyDB. And then for the inferencing and the embeddings model, we'll be using models from Vertex AI. These are just some of the simple ways to build this. Now we'll be going into a bit more detail and covering the RAG approach. Now we'll be describing it in a few different angles so that you can actually grok the process and how it works. In my demo, I'm going to cover in 5 steps. First, we're going to initiate the instances. We're going to create a database. We're going to enable vector search. Then we'll populate the database with some sample data. Then we will launch the Cloud Run application service. And then finally, we will test and connect the application. All right. So here's kind of the high-level overview architecture of the demo. Different GenAI applications have different ways to build it, but this is sort of the standard template that we're seeing a lot of customers build. First, there's the initial data ingestion stage up top. This is sort of your pre-step, as we mentioned before, where you're going to put your data, whether it's user manuals or policy documents or flight information, like all your domain data is ingested into a database using the RAG approach, and those are called embeddings. Once those data is inside your database, your serving subsystem, which is basically app, will retrieve that data and serve it. There is an optional subsystem called quality evaluation that you might want to consider for production applications where you want to increase the accuracy of your applications. This is the detail view. I know you can't read all of it, but we'll be going into each of these subsections in detail as we go through the demo. All right, so for the first demo, we're going to run a simple SQL script to create a database. Now, we've already created all of the AlloyDB clusters. We've done all of the compute instances, and we just enable a database, a SystemDemo database, and then we're going to enable a vector search. In Postgres, this is pretty simple. You just have to create an extension, and the vector is enabled. Just 2 lines of code. Very simple. And so one of the questions we also get is like which database to use, and it really does depend. If you ask me from the product side, we think AlloyDB is probably an excellent option to get started because it offers all the latest innovations in AI. It's open source compatible. It's much faster than open source because we've done some optimizations. But if you're starting with MySQL or SQL Server or Postgres with 100% compatibility, Cloud Run also has pgvector, as other cloud vendors as well. So this you don't have to start with AlloyDB, but we recommend because it's a great place to start. But there are other options out there as well. Now I'm just going to install a few packages to get this started, but we'll let this run for a bit while I cover the rest of the architecture. So the first step when you're building an application is the data ingestion stage. And for those of you who have a data science background, this is pretty much the data engineering part. You want to make sure that you have the right data inside to be able to have the factual responses that your application can respond with. In the old days, most of the time, I'd say 70% of the time was the data engineering, cleansing. This is kind of like that. There's no separate training or evaluation because everything is kind of done in the LLM. The part that you want to make sure is you want to make sure you have your raw data, whether it's documents or databases or flat files. Those files are stored in a blob storage like cloud storage or cloud storage service bucket. And then using a messaging service like PubSub, those are ingested into Cloud Run. You can use any service you want, but in our case, we'll use Cloud Run. That's serverless, fast, and simple to get up. The raw data, whether it's document format or whether it's files or databases, those are embedded into embeddings, as Harish mentioned before, into a database like AlloyDB with vectors. When you embed that database, you want to use an embedding model. There are various models out there. For example, if your raw data is text, let's say it's a user manual or like the COBOL manual. One fun example is we once sent the entire COBOL manual into an LLM and had that used for migrations, and it was able to do that. But regardless, if you have text data, you want to use a text model and convert those into embeddings into AlloyDB. Here, so raw data goes into a blob storage messaging service, kicks off a processor. You can use a document AI service to parse it out, or you can use embeddings model to parse it into embeddings into the AlloyDB. Now, once the data is inside AlloyDB, that's when we can get the action started. So now that we have the database instance created, we have vectors enabled, the next step is just to populate the database with our sample data. And we're just going to retrieve a Git repo and have all this done for us. One of the questions that I get the most is, while this runs, is which database to use. Now, in a parallel universe, at this exact same time, Andy is doing a spotlight on what's new for databases. So I'll just give you a kind of a quick recap. We are announcing vector search support for all of our databases, including Spanner, AlloyDB, Cloud SQL. Bigtable is coming soon. Firestore is new today, as of today in preview, and then also for BigQuery for data warehouse. And so depending on where you're running your workloads, you can choose a database that fits the best. As I mentioned before, AlloyDB is a great place to start. It's open source compatible. It's 4 times faster for transactional queries. It's 4 times faster for vector queries and up to 100 times faster for analytical queries. And so AlloyDB is kind of a good default place to start. If your data is already running in MySQL, SQL Server, or Postgres, and you need and require 100% compatibility, Cloud SQL is also a very good place to get started since you can just lift and shift into Cloud SQL. And then last but not least, if you have a really large data set and you need unlimited storage and you need cross-region replication, multi-master. Spanner probably has the highest scale as an operational database. If you have more scale than that, and if your data is in a data warehouse like BigQuery, BigQuery has vector support too, and so that's one area where you can also directly use BigQuery. Okay. So now all the data is ingested into my database. Let's talk about the actual application. So in the application, now I know this font is kind of small, but I'll walk you through it. The actual questions from the users up top come in the form of natural language. For example, it'll ask things like, what's the return policy of this retailer? Or what's my flight information? These things will be difficult for a standard LLM to answer because they're based on real-time data. And so those natural language questions get parsed into a backend, and it changes those natural language into something the database can understand in terms of SQL. Today, we're announcing LUDB, LUDB AI, natural language interface, as well as some security models to make this part easier. We'll share some sessions to learn more about those. Basically, all of those queries get transferred into something the database can understand, and it uses semantic search that Harish mentioned before to find the real-time information. For example, our company has a different return policy than the average 30 days. Maybe ours is 60 days. It's our competitive advantage. And so those specific domain data, such as a specific return policy or flight information in the database, will be found and retrieved back. Once that answer is found and retrieved, that return policy or flight information or your specific data is constructed together with the prompt in the application using LangChain. And that is sent to Vertex AI, where the LLM will take all the different pieces of information, format it nicely into a natural language response. Now, before it sends it back to the user, sometimes it will have a log to make sure that we can analyze it after. You can send it to BigQuery for analytics. And then just before it sends it back to the front end, it'll run it through a pair of filters to make sure that it's not biased and whatnot. And once those answers are good to go, it'll send it back to the user. So now that we have the data populated, we are going to run a simple application, a simple Cloud Run instance to set up this. And then the Cloud Run instance will run the extension service. Now you can run this separately or as part of your application. That's the choice you want to make. Usually if you run the RAG service separately in Cloud Run, it'll have better performance, sometimes better accuracy as well. So we recommend doing that. But again, we'll let this run for a few minutes in terms of building the containers and updating the sources. Another question that we get often is, when should I use GKE versus Cloud Run? Now, also this depends. If it's a simple application and you want to utilize the latest in terms of serverless, pay-as-you-go, Cloud Run is a great place to start. If you need more controls, more knobs, GKE also, it has more controls and more options in those areas. But because both are based on containers, you can also move it one to the other as well. So you have that flexibility. Before we go to the last step, let's talk a little bit about the evaluation subsystem. Now this system is optional. Like if you're just doing a test run, you probably won't need this. But if you're thinking of bringing your application into production, you're going to want to look into how do we make the applications better. Now, even in an internal test, like we don't usually get it right the first time. So it's an iterative process. And so what this does is, all the answers that the application sends back, we also log it separately so that we can analyze it in BigQuery to make sure we improve the accuracy and the answers based on the system. And so there's a separate subsystem called the evaluation that you want to do. Think of this as similar to the classic ML process where we're evaluating data to make sure our models are more accurate. Okay, so now that we have the extension service running, we're going to deploy the sample application. It's a simple, it's also a simple process that we're going to run through Python. We're going to deploy the application and the sample data. We're going to create a very simple application called Symbol Air, which is a fictitious airline company where it will help you with a support chatbot that will respond to users on their flight information and so on and so forth. As part of this, we're also going to install LangChain, which will help with the authentication between the different agents, the database, the application, and the inference models. So before we actually show the application, here, I'm going to summarize what we just showed before. The user on the left-hand side will be asking the natural language, such as, what time is my flight, right? Sometimes it's very vague, and so the application should be able to clarify what those questions are. The application, now in a typical LLM app without RAG, it'll just go directly to the LLM model and find a generic answer. And most likely, if you ask something like, what's my flight information, it'll just give some random answer. Or if you ask, what's the return policy, it'll just say, on average, it's 30 days for most companies. But with RAG, you have this separate process where you're going to ground the LLM based on your data. It'll run a retrieval service. In this case, we use Cloud Run. It'll retrieve the data using semantic search from a vector-enabled database like AlloyDB. Once it gets the data, it returns back. The application uses an LLM to construct the prompt, get the answer, and then sends it back to the user. And so in this case, it's kind of like a three-tier architecture that you've seen before, except there's the app layer, there's the inferencing layer, and then there's the database layer. So in the last part of the demo, we're going to tunnel into the application. I'm just going to use a web preview. It's a very simple app, symbol layer. And it's a symbol layer chat bot where we're just going to ask a question like, when is the next flight to Denver, for example. Now, the app is smart enough that it wants to know the date. Like, there's multiple flights to Denver, so I need a date for that. And if I write tomorrow, let's say for tomorrow, it's going to search the database, find the flight information from my database, and tells me the flight is 10:55 tomorrow morning. Now, I also want to ask, when can I get coffee? Where can I get coffee in this flight? And it already knows that it's asking for the flight information, the coffee shops in the landing zone. And it'll say that there's a Starbucks coffee near gate C18. So this is sort of the power of LLMs. Like, it's really good at creating these natural language responses. You just have to give it a little bit of the augmentation with your data to make it very useful for enterprise customers. Now, I know the demo is pretty hard to see because we went pretty fast, and so everything that we showed you today is on Code Labs. We built a lab that you can run yourself, and there's a QR code here if you want to take a picture and then download it yourself, or you can just go to the Code Labs and search for GenAI DB Retrieval app. And the session is recorded, so you can also watch it later as well. Oh, and as part of the Code Lab, we also have a GitHub repo. And so if you want to customize the demo for yourself, you can also fork it and customize for your needs as well. And by the way, we showed you a sample application, and it's a sample architecture. This is a very typical RAG structure. And so you can switch out the components with different services. For example, an alternate architecture uses GKE for the application subsystem, and it uses Cloud SQL for the database vector enable. Again, PG vector is enabled for any Postgres database. In this case, you can use Cloud SQL and some of the fully managed capabilities of that database as well. The third kind of most questions that we get often is, what are the different products that map to each? And I've sort of hinted along the way, but just to summarize, on the far right top part is, there's Vertex AI, which is pretty much used for both the embeddings for the actual data into your data. It's also used for the LLMs to do the inferencing. There's sort of two major options. For the compute layer, you can use Cloud Run for a serverless, easy to get started for the compute layer, or you can use GKE if you need more options and knobs. On the database side, we have a few options: Cloud SQL, lift and shift for MySQL, Postgres, or SQL Server. It also has the vectors enabled for those. AlloyDB is a great database, again, to get started with better performance, better scale, availability, but also open source compatible. Now, if you really have a high scale, all those needs, Spanner is a great database with multi-master, multi-region, advanced consistency options. If you're building a application base that needs really fast writes, NoSQL databases are really good for that. And so Bigtable, coming soon, will have vectors enabled for that. And so if you have applications like in IoT, for example, and you really need to have single-digit millisecond writes, Bigtable is great for that. And then if you're a mobile app, it's based on, let's say, the Firebase ecosystem, or you have a Java-based application or a JSON-based application, Firestore is an excellent choice as well. Our goal is to provide vast support for databases. Oh, and what's missing here is also BigQuery. If you have your data in a data warehouse, you can also build the GenAI applications with RAG support in BigQuery as well, since BigQuery also supports vector search. All right. So how to get started? There's a few options that we recommend, but I think the biggest choice is the choice of the platform. And there's various vendors out there that offer different ways to build it. I feel like Google is the only vendor that has the full stack, from the TPUs, the actual inferencing engines, the models, the databases, the compute, and all the AI tools. And so you want to choose a vendor that has the full stack. It's probably easy because everything is pre-configured. You don't have to kind of put things together. We offered a unified platform for that. The second part is all of our databases have vectors enabled, so you don't have to be forced to choose one. You can choose the best one for your workloads. For example, if you have a specific needs for like microsecond latency reads, even memory store, which is a Redis-based cache, can do that as well. And so choose a tool that best suits for your needs. And then, of course, we didn't cover much today, but Gemini is enabled for databases in preview as of today. And so you can use Gemini to accelerate and simplify your database management across all of Google Cloud. Many customers, startups, I know it says 70% now, but it's closer to 90% as of last week, are using Google Cloud to build their GenAI applications. And so this was sort of the overview of using containers, compute layers, databases, Vertex AI, and how everything kind of comes together. Now, there are deeper dive sessions that go into each of these topics. There's a session on kind of the overall roadmap of where we're going with databases. There are sessions on specific RAG-based application approach where we go deeper into how you actually build applications. There are sessions on the Vertex AI side where we want to learn more about the models and the inferencing and link chain. There's models about how use cases and design patterns. There are sessions on the actual vector databases that go deeper. And then there's a link chain. Now, if you're interested in like the demo portion of today, we have a Expo Hall Innovators Hive led by Gleb, who's going to go through in deep, so you can go and talk to him to learn more about chatbots and how everything fits together. He also built this demo for me, so you can talk to him in terms of details of how everything all runs. We have a new book, Infrastructure GenAI. Feel free to take a picture and download that if you want, on how to build GenAI apps with our infrastructure services. There's a few options and some offers for Google. And most importantly, feel free to give us 5 stars if you enjoyed this session. If not, you can give us comments and the feedback. But we really enjoyed having you here. We're excited as you are in terms of the future of GenAI and Google Cloud. I really hope you have a great rest of the week. Thank you so much.